Okay, welcome to Unit 2. So in the first unit, we were focused on one set of data at a time, and I know we compared box plots and we compared back-to-back stem and leaf plots, but we didn't compare one experiment that would have two different groups that we're comparing. So in this whole chapter, or this whole unit, we're focused on comparing two different variables. We're going to be looking at scatterplots and correlation and variables today, and then we're going to continue that as the week goes on. So scatterplots, you probably, let's see if I can shrink this. Okay, there we go. So scatter plots, you have seen this in Algebra 2 and probably pre-calc. So scatter plots are used for two sets of data. Okay, so we're looking at patterns, or what we want to look at with scatter plots are patterns, trends, relationship, and outliers. And I'll give you a list of exactly what you need to write about when you look at a scatter plot. So here we have a picture of a scatter plot. You see all these little ordered pairs is really what they are, and on the x-axis we have an explanatory variable and the y-axis response variables. I'll get into all these definitions in a little bit, but for now I just want you to get an idea of what a scatter plot looks like. These are all different pictures of what scatter plots can look like. Okay, and a scatter plot is used to show an association. So that's the key word you're going to be hearing a lot, association, between quantitative variables. Okay, so this is not for categorical variables, it's only for quantitative variables. So things you should notice. Well, you have all these ordered pairs. They form maybe some sort of picture. They could be closer to a line. They're spread out. This one forms a bit of a curve. Okay, so and we'll talk about what a moderate positive correlation looks like. But you should be noticing that the dots on here are closely related together, or maybe they're a little bit spread out, or maybe they're really spread out, or they form a curve. So it's the pattern that they're forming is what you want to be noticing with a scatter plot. And all of these ordered pairs represent data points. So if I was comparing this particular point, so what is it on the x-axis, and then what is my answer or my response on the y-axis? So each of these are an ordered pair. So there are four things that you want to look at. So remember when we talked about histograms and data, you were to make a list and write about the different things that you notice. So with scatter plots, it's these four things. So you're going to just make a list and discuss these four things. Direction, form, strength, and any unusual features is what you're going to be looking at. So direction, does the data go in a positive or a negative direction? So what you want to look at is really slope. If I was drawing a line through this, which we'll get to later, does it have a positive slope or does it have a negative slope? But we don't talk about slope, we just talk about the direction. So is it a negative direction or is it a positive direction? That's what you want to note when you're talking about direction. So form, what type of shape is this going to form? So this, do you want to, when you're looking at all of these ordered pairs, does it kind of form a line? This one kind of does. I know that there are points that are not exactly on the line, but generally speaking, this is a linear relationship. If one goes up, the other one, if the other one goes in the other direction, right? If this one's got a negative relationship. But you want to look at, does it form a line? It doesn't have to be a perfect line, just can I draw a line on it, and that would be the form. Okay, so that's one option. The other option is that it forms a curve. Okay, so you would note that a curve is formed. So this one has more of a gentle curve like this, kind of an exponential looking graph here. This one has a sharp curve like this. Okay, so again, you want to note those different kinds. We are not going to be looking at anything like this in this stats class. So really your choice for form is going to be it's either linear or it's a gentle curve. Okay, we will be talking about this type of curve and what we can do to actually make it straight. But for now, you're just going to list, is it linear or is it a gentle curve? The other one we're going to talk about is strength. Okay, so direction, form, strength is the third. And with strength, and we'll talk about correlation in a little bit in this video, but two different things that you're looking at are the points closely together. And I know they're not right on top of each other lined up, but are they closely related to each other or associated? Or are they kind of all over the place like this one is? All right. So there really isn't a pattern here. It's all over the place. And you would not describe it as all over the place, but you would say that there is little association from one to the other, or you would say that there is no discernible, is like, I can't really tell if there's any sort of trend or pattern. You can't discuss if there's a line or a curve in this because there isn't any. It's scattered all over the place. Okay, this one, they are more close together, so it follows a single stream is what this slide is saying. But does it look like it forms some sort of line or curve with the other one? But this is how closely related are they? Okay. And then the last one, you're going to look for any unusual features. So here's where your outliers are going to be. Okay, so outliers or clusters or subgroups are the other things that you want to be looking for. Okay, so I tried to find a picture that had clusters and subgroups and also an outlier. So just by looking at this scatter plot, excuse me, you would notice that this is an outlier. So this study is looking at study time in minutes and whatever mark or percentage somebody received from or on a some sort of assessment. Okay, so this person studied a lot, 2 hours, 120 minutes, but got like a 65 on the test. Okay, this person studied 60, well, what is that, like 70 minutes and got a 53 or so on the test. Okay, this person studied 150 minutes, a couple people in here, and got like an 85 or 90 on the test. Okay, but this one is an outlier because it's far below the other ones. And with outliers and scatter plots, we will define it a little bit more, but for now, you're looking at the picture and then you're determining, well, is there one that's really far apart? Okay, clusters or subgroups, I think this is sort of a cluster. They are really close to each other, so you would say that somebody studying between 170 minutes would get, there were many people who got around a 90 on the test. Okay, so outliers, clusters, or subgroups, you want to notice that as well. Okay, yeah, yep. Okay, all right. So two different types of variables that we have with scatter plots. Okay, so there needs to be a variable for the x-axis and there needs to be a variable for the y-axis. Okay, so when you create the study, we have another chapter or unit later where you'll be looking at different studies and determining which one goes on the x-axis and the y-axis. So it really depends on what you're looking for. Why are you setting up the experiment that you're setting up, and what is it that you are expecting the outcome to be? So that's the reason why we have these two different variables. Okay, so the explanatory variable, we have some examples as well. The explanatory variable is what goes on the x-axis. It is going to explain the other variable. Okay, so the predictor variable. All of these are words for what goes on the x-axis. So the explanatory or the predictor variable is what goes on the x-axis. It is going to explain the other one. Okay, the response variable, so that's what we're looking for. We're looking for what exactly happened, what's our outcome. So that's a good way to think about it too. What is the outcome of the experiment, and that's what's going to be on your y-axis. So the predicted variable, and this is the word that I want to make sure that you use for the y-axis, because we will be looking at notation that will be talking about the predicted variable. Okay, so the explanatory variable is the word I want you to remember for the x-axis, and the predicted variable is what goes on the y-axis. Okay, and here's some examples. So I know in math we talk about the independent or the dependent variable, and sure, that of course that works with this as well, but I think when you are looking at scenarios, it is important to think about what's explaining what and what is your response, to remember what it is. Okay, so response, or I should have written on here predicted. is the other word that I want you to remember. Okay, so here I have some examples. So I'll do the first one and then I'll pause the video and you can do the others. Okay, and in your question you're going to be doing some more explaining instead of just choosing which one. Okay, so here's A. An experiment was conducted to test the effects of sleep deprivation on human response times. So what I'm thinking about this is, well, sleep deprivation on human response times. Okay, so will their responses to something, whatever, an event, choosing a card, whatever it is, will that be affected by less and less hours of sleep? Okay, so in this experiment, probably, we are having people sleep less and then we're timing how long it takes them to complete something. Okay, so my explanatory variable is the sleep deprivation, or the number of hours of sleep. And then my response variable, what I'm looking for, is response times. So go ahead and write these examples down and then you will answer them and we'll come back. Okay, so this one, the experiment to ascertain, which means like to figure out the effect of deep sleep therapy on mental disorders. So my explanatory variable is deep sleep therapy. And my response is the disorders. Okay, the effects of detergent concentrations on germination of seeds. So I'm going to have different detergent concentrations here that is going to affect the germination of the seeds. Okay. Okay, so we are going to spend more time in class tomorrow or on Monday talking about correlation, but I just wanted to give you a kind of an overview. So correlation, you have to make sure that you're not using the word cause. Okay, causation. I will talk about this a lot more. So correlation doesn't equal causation. One thing doesn't cause something else. We're just simply looking at the relationship and how well or not well, I don't know, the association is between two variables. So in this case, and this is all data that I got from, I think this is from your book. Okay, so if I looked at statistics students and I measured them and I weighed them, this is a correlation between, or an association between, the heights in centimeters and the weights in kilograms of this group of stats students. Okay, so we can see that it is a positive relationship. It forms a line. I do have an outlier up here. These could be considered outliers, but this one is really an outlier. And they are tightly together, so we would say that there is a strong association. So this is where we actually start talking about correlation. Okay, correlation is figured out. I should go back to here. Correlation, there's a button on your calculator, so it'll tell you what the value is. And then in class, I think tomorrow, we're going to be talking about what that number actually represents. Okay, but here's some conditions before you say yes. These values, we can say there's a correlation or an association. Okay. And this is good too. It measures the strength of the linear association between the two variables. Okay, so here are 3 conditions that you need to be careful of and watch out for before you decide that correlation you can talk about the association. So you have to make sure that you're using quantitative variables. Doesn't apply to categorical variables, so that's a no-no. Make sure that they're quantitative. Okay. The next one's straight enough. It has to be a line. It can't be any sort of curve or anything else, but it must be a line. You're going to get a weird answer. It's not really going to make much sense if it's not linear. Okay, so that's the straight enough condition. And then the last one is outliers. You want to figure out the correlation with and without the outlier. The outlier may be throwing off the data and maybe throwing off the correlation, and maybe there's another reason why you have that outlier. So that's why you figure it out both ways, and then you can discuss that as well. Okay, and then that is it with notes.